False start. One sec. This is the only lecture that I'll record, so please come to lab. Don't rely on recordings. But okay, anyways. Howdy guys. So this is lab for CCE 313. My name is Mary. I'm gonna be your TA. This is my 4th time teaching this class, so I'm pretty knowledgeable about it.
I'm Wayne. I've seen some of y'all's these faces before in my office hours in the past. I'm the peer teacher for this section. This is my 2nd year teaching 313. By the way, this we did out of the way. My office hours this semester are actually remote only. Sundays from 2 to 5 p.m. on the PT discipline.
Cool. Yeah, and we'll have all of the office hours up hopefully by tomorrow. We're still finalizing it. But we try to have office hours every day of the week. And you can go to anybody's office hours, so you don't have to go to just me or Lane's office hours. But cool. So today we're just going to have an overview of your lab to show what we're going to be doing, expectations, how to get the most out of this lab, stuff like that. So it's not a rigorous day, nothing to do at the end of this class. Also, before I start with the slides, I want to show y'all on Canvas. Hopefully y'all have already seen this, but I'm just going to point out a couple things. So in modules under student resources, the first thing I'm going to show you is the master plan. Sounds very grandiose. Master plan or supervillainy. But this is super helpful. I reference this a lot when I get questions about when things are due, what we're going to be doing that week, when PA kicks off. Look at this, and that should give an answer to those questions about any due dates or content. It's super helpful. You'll also see like when we're having the assessments, and those assessments are always in this class during your section. Yeah, so that's super helpful resource. Look at that. Also the syllabus, let's point this out. I don't think I have a slide over it, but I'm gonna go show y'all real quick. At the end of the syllabus, it has all of the normal stuff. But what you will care about is this late submission policy, specifically for PAs and LEs. What we give you, and read through this for the actual details on points, but we give you 5 days total pool of late time, and you can submit PAs late. So say you're late one day on PA1, you have 4 additional days to be late on the other PAs or LEs. This is different than previous semesters, so I just wanted to point that out. Read that for details on for the math, but does that make sense for everybody? More or less. Yeah. Cool. Is there anything else I want to go over in resources? Yeah, so Microsoft Teams, is everybody on our Microsoft team? If not, check it out. This is where Dr. Tiagi is going to send announcements. This is where we're going to answer like really common questions people are having. It also has the FAQs for PAs. So it's really, yeah.
He posted one thing in lecture content that said something. Nothing needs to say the
do you see all of these chats? Okay, yeah. So you've got a message board, but like when we start PA1 stuff will populate here. So
at some point he's gonna make something in social post asking everybody to introduce themselves, and it's really cute. It's good kind.
We did that over the summer, but it was just me and Min posted. Nobody else posted. It was sad. So post on social. But yeah, if you see this, you're good. Cool. Okay, is there anything else I want to talk about in modules? I think that's it. Academic resources, student resources, office hours. I don't think this is populated yet. Yeah, this will be published. But cool, let's get into details for our lab. Okay, so attendance is not required. It's highly recommended, and really there's no penalty for missing a lab section. It's just you won't get any help. But if you miss a lab section, these are here for y'all. So it's not tracked. You can go to any lab section you want. That includes other TAs. So if you don't learn great for me, you can go to Gabriel, you can go to Harsitha. Yeah, that's fine. And then when we're doing presentation, don't like listen to us, don't get distracted. This happens a lot. Like I have people that they'll come to my first lab and stay till the end of the day. But they'll be like making noise while I'm trying to talk and it gets distracting. Anyways, yeah, normal common sense stuff. Cool. So we have 4 different types of labs. So when you come to lab, we're not always going to be doing the same thing. It kind of breaks down into these 4 different categories. The first one, it's a live demo where it's just me introducing a new topic and you'll watch me code. We don't do this so much, but it's one type of lab. The second type of lab is probably most important for PAs and LEs. It's the intro one where I present what you're going to be doing for that PA programming assignment or LE learning exercise. The third one, I don't have any presentation. It's just y'all coming for support with the current PA or LE. Then the fourth is a skill assessment. So you do have to be in your assigned section for skill assessments. And these are tests. So you have 3 tests that relate to lecture and 3 tests that relate to lab. And those are going to be proctored during your lab time. Yep. Any questions on this stuff? Sweet. Okay, so this is how the grade breaks down. PAs are worth 48%, and we have 4 of them. You get roughly 2 weeks to do them. These get pretty intense, so start early. Yep, that's my biggest tip, is to start early. Lab exercises, 16%. We have 7 or 8 of these guys, and it's about 1 week. You can get them done in like a big coding session or a couple days. They're a little less intense. And then skill assessments, those are your tests. Yeah, so 79% of your grade comes from programming. So it's a programming heavy course, lab matters. And then we've had issues in the past with people sharing code. We run your code through Moss, so it's pretty easy for us to tell if you've copied code or if you've copied code from previous semesters or public repos. So don't do that. You're free to share concepts, but actually emailing each other code is not okay. Same thing for GitHub Copilot. We're seeing that a bit more. It's not even that great, so
Not yet.
don't. Yeah.
It's also the sample you gave me at all.
Yeah, so don't use it. Yep. And we like, if you should have all of the information that you need for this class listed in Canvas or Teams. If we don't want you to see it, it won't be in Canvas or Teams. So check those 2 sites. Don't look elsewhere. Cool. So these are the details of our assignments. So you have PAs, which are project level. They can take up to 20 hours to complete, and they could take even more. It depends on your familiarity with C++, really, how long they're going to take. But 20 hours is a pretty reasonable estimate. And again, they take probably around 100 to 200 lines of code to do. So they're not that long of assignments, but learning the concepts and figuring out how you want to code it and really understand the material is key. If you don't do that, then you'll have spaghetti code, and so nobody wants that.
200 lines, you do it right. I've
seen
some creative solutions in the past of around 2,000 or 1,000.
I haven't seen that many. That's insane. Yeah, so take it clearly, make sure you understand the material, and then start coding. That really helps. And draw flowcharts if you need to. I still draw flow charts. So lab exercises, these are like somewhere between live demos and PA difficulty. They're designed to help you with skills that you need for PAs. So we'll give system calls that you're going to be using, teach you some of the logic or algorithms that you're going to need to apply to PAs. They take about 6 hours to complete, so they're much less intense. But even then, you only get a week to do them, and so still start early for that. And then skill assessments, these are the tests. We have 3 that are specific to labs. And you can look in the plan to see when those are assigned. Any questions on this stuff? Cool. Okay, so help resources. We have a ton. The first one is self-help. So get some GDB experience. We have a couple videos and modules on Canvas that are going to be released with week 1 content to help you with GDB. So you'll get pretty familiar with that. Address sanitizer, that helps you with memory leaks. You can use LLDB if you use a Mac, and you're really not supposed to use a Mac, but people do.
Yeah, you're running the virtualized, so you'll have GDB.
Yeah. So yeah, get familiar with debug tools. Those really help you. It'll give you more information than just doing a bunch of printf or cout statements.
Later on, like strace might be helpful as well.
Yeah, and the autograder uses strace. So if you want to read autograder, learn strace. So Microsoft Teams, as I already said, that's where we're going to be giving you information. You can ask questions. We also have this tag, this 313 TA fall 22 tag. That'll give all in your teaching team a notification. So that's better than DMing one specific person. The only time that you would DM one person is like if you had questions about grading, just you can DM your TA or me directly. All other times, if you have a question, reach out with that tag. Office hours. I already talked about this. We'll post it soon, and we should have office hours every day of the week. And feel free to DM or email me to set up a one-on-one appointment. We can do that too. Yeah, email. We get loads of emails. Y'all get loads of emails, but you can still email us and we'll respond reasonably well. Also, what we're trying to do in office hours is not to code for you or debug your code for you. We're going to give you like conceptual information that you need or point you in the right direction on debugging. If you run into an intractable error, I will help you. We can work through it, but it's really more focused on helping you figure out how to debug your code. Cool. Any questions on this slide? Sweet. Okay. So general tips. It's a 4-credit class, so it's pretty important. A lot of people say that it's one of the hardest classes they have to take. So, and especially if like, how many of y'all are taking 315? Okay, yeah, I get people complaining that like them at the same time is tough. So make sure to start early. That's my biggest piece of advice. And utilize office hours too. Don't be discouraged by bugs. So since we use C++ and on the Linux side, you're going to see a bit more intense dumps and bugs and traces than you're used to. So it can be overwhelming at first, especially if you're not used to C++. But we'll go over it and you'll be a pro at reading traces by the end of this, I'm sure. And just like I said before, make sure you understand the assignment before starting to code. This avoids doing some spaghetti code and interesting logic. Yeah, if you're coding more than 1,000 lines, stop. I would say that's a pretty good tip. Okay, so I wanted to real quick go through a couple examples of error messages. I picked out 3 super common ones. I'm not expecting you to like know exactly how to debug this, but this will be a reference for you in the future when you're trying to do stuff. But I wanted to highlight a couple things that'll be useful while you're debugging. So this is what one of our dumps looks like when you're trying to run your code. So you can see I tried to run it and then I got a stack buffer overflow. So you can see the type of error right here, stack buffer overflow. So that means we're trying to reference a address location that's outside of the buffer that we've allocated. And it's been allocated on the stack. Yep. And this can actually be Googled. Like you can Google stack buffer overflow and get some tips. I'd say practice judicial use of Googling. Don't Google like how to implement this assignment, but you can Google like I've gotten a stack buffer overflow. What are some causes? So once we know what error we have, you can see if it's a read or write, and that helps to know what variable is causing this. So a lot of times it's not super clear which variable in the line is causing the error, but if you know if it's a read, it's likely going to be on the right-hand side of your line, and if it's a write, it's the variable on the left-hand side. That helps. It's not foolproof, but it helps. Then the next, arguably most important part is this trace. And what I like to do is I like to start at that #0 and work my way down until I see a file name that I understand or that I recognize. So I don't know what that is, so we're going to skip it. You'll get really familiar with this client.cpp file. We use it in a lot of our PAs. So you see, okay, client.cpp is the first line that I recognize. Its line number is 39 that's complaining. So you head down to the file, check out line 39 and see, oh yeah, file message is only 24 bytes long, but max message is 256 bytes long. So I'm trying to read 256 bytes into a buffer that's only 24 bytes. So there's a mismatch there. I don't expect that all to make sense right now, but those are the steps that I'd expect you to go through. Hopefully that seems all right. Cool. So yeah, the stack buffer overflow, those are super common. Another super common one is a null pointer, null reference exception. I'm sure y'all have all seen this. Same things apply here. We have a null pointer error that we can see here. And then we're trying to reference a null pointer that should be type FIFO request channel. We can read into the trace. That is the object that we're trying to reference that's null. So that's probably not what we need to look at. Client CPP line 125 is the first affected one, or the first one that we're trying to call the object that's null. We go down into this guy and see, oh yeah, Chan hasn't been initialized, it's null. So yeah, so same concepts, just read through the error messages. So the last one I wanted to talk about, again, super common, is a seg fault. I'm sure y'all have all seen a seg fault too. But in this case, we're getting an unknown address of all zeros. So this also means probably it's an uninitialized variable caused by a write. So the variable is on the left-hand side of the line. We read in, I recognize that first file, client.cpp, line 39. And yeah, buff hasn't been initialized. So that's how to read a trace. Hopefully that's helpful in the future for y'all. Cool. Okay, best practices continued. Commit early and often. I have had plenty of people over 2 years come to me really upset without code, like my computer crashed and I lost all of my code. And then I say, yeah, so clone the latest repo, clone the head of your repo. And they're like, oh, it's the initial commit. And I feel really sad. but I can't do anything about it. So commit early, commit often. If your computer crashes and you don't have access to your instance on your computer, if you have committed your repo, you can go to any of the open access labs and create an AWS account, create a Cloud9 environment, and clone it from there. And you've lost like a couple hours of time. So it's not so bad. I'm sure you've heard that advice like plenty of times, but use it in 313. Reasonable commit messages. This lets you know what you've been doing, what you've tried in the past. It's super helpful to see logical commit messages when you're looking at your GitHub repo, especially if like you're trying to figure out where a bug was introduced in your code. Practice dry coding. Hopefully all of y'all know what dry coding is, but abstract out into functions so that you only have to change one thing in one place. Yep. I'm sure everybody's had a bug where like, I fixed that code, and then you realize, oh, it was copied and pasted into a different location. It's super helpful to practice dry coding. Like I've said a couple times, learn how to use a debugger. So that's GDB or address sanitizer, LLDB, whatever you're using, and read a trace. And we just read a trace, so yay. Yeah, we have GDB documentation that will go live next week. Yep. Okay, also learn how to run the code. This is surprisingly, I get this surprisingly a good amount of the time where people only run make test to debug their code, which is so confusing to me. Especially since the auto grader that you can run with make test, and we'll go into that in a bit, but it only runs 70% of the test cases that we test your code on. So if you only run make test, you might just get a 70.
Yeah, like the other annoying thing is like somebody will ask you for help and you go over to the computer and like, look, what's wrong? And they go make
Make
test.
test.
And you
Yeah.
sit there and watch and go through all the tests. And they're like, wait, come on. Like,
Yeah, and make test will only tell you, oh, that test case failed. Like, I don't know anything more. I know it failed. Do you know what could cause this? No, I know it failed. So learn how to run your code. And that is, I'm sure everybody has done this before, but it's / executable name plus any arguments. So that's the first way that you should run your code before ever trying to do a make test. I mean, compile it, but then run it. Second way is run in a debugger. So do GDB space your executable name, and then you can set breakpoints. Once you hit those breakpoints, you can print out variables, you can step through your code, you can step into functions, you can step out of functions. It's super helpful. I'm also sure everybody's used to debugger before. And then make test, that'll let you know if you pass all of your public test cases. It's also what runs on GitHub in our GitHub Actions. Cool. Sweet. Okay, so this all boils down into these couple tips where we want you to read the PA documents quickly so that you can ask clarifying questions. And if you read the PA documents, we will release them before lab time, so you can read before I present them, and then you can ask questions and get more information out of your lab, which is always good. And then attend the intro labs. Again, for when we're just doing intro PA LE labs, you can go to any section that's convenient for you. Go over all the materials, read through the FAQs. And then if you're stuck on an error and you've tried a couple things, when you email or DM us for help, let us know what you've tried so we don't like start with that. That's pretty helpful. Okay, so these are a couple messages that I've picked out from previous semesters. In the first one, they were asking for help at 11 p.m. when the assignment was due at 12 a.m., like in an hour. I also go to sleep at 10 because I'm an old person. So I won't respond to you after 10. And then on the second one, so the assignment was due before spring break. And people in spring break were really complaining that we weren't responding to them. But and this is a tough situation. But if the assignments due before spring break, get all of your help before the assignments due. We don't have a spring break, but I don't know, Thanksgiving. Cool. And then also read the error message. That's kind of one of my main pet peeves if somebody doesn't read the error message and the error message tells them how to fix the problem. So these are two really common scenarios that I get where in the first one, it's the difference between accessing the members of a pointer versus the members of an object. So objects, you use the dot to reference their members, and with pointers, you use an arrow. And the error message tells you that. So it says, maybe you meant to use an arrow. So that helps. Same thing with this guy, alloc dealloc. So if you have an array that you've allocated on the heap, you deallocate with delete square brackets. And it tells you that. It says operator new brackets versus delete. So really what you should take out of this slide, read the error message. And then I put this twice because it's a pet peeve of mine. Don't use make test to debug your code. If you have a test that's failing, what you can do is go into the patest.sh file, and you can see what that test case is running. So in this case, this test case is running this ./client W100, this line. So you can run that line and get the actual error messages that we're running into. And that's a lot more helpful than just running make test. It's also a lot faster because make test can take a while to run, depending on which one, like what PA it is, but cool. So that is all I have. I like this class. I've liked TAing for it. And I think you learn a lot of useful information about it, but any questions?
I want to say Dr. Tiagi is a very good professor. You guys are very fortunate to have him.
Yeah, he's cool.
Guy. If you get the chance to get to know him, I definitely recommend it because, I consider him a good friend and he's done a lot for me. So
Yeah, he's a cool guy. Great. Well, that's all I have. So y'all are free to go, but see ya.
cool.
I have a question. What was the difference between the no point error and the psychologist?
Yeah, so let me this one.